So in Java, you're probably pretty comfortable with a basic if-else statement, right? It's like a fork in the road. Either go left or you go right. Simple. But what happens when you get to a roundabout with like 5 different exits? How do you tell your code which path to take? Well, that's exactly what we're going to tackle today. We're going to build the perfect tool for that job, the if-else-if ladder.
So here's the game plan. First, we'll lay out the problem we're trying to solve. Then, I'll introduce you to our new best friend for this kind of thing, the if-else-if ladder. We're not just going to talk about it, though. We're going to jump right in and write some code. After that, we'll level up and see how to make that code even smarter, more efficient. And to wrap it all up, we'll go over the key rules so you can walk away feeling super confident using this in your own projects. Sound good?
Okay, let's dive into section 1. We're not starting from scratch here. We're actually going to build on what you already know. Think of it as upgrading from that simple fork in the road to a much busier, more complex intersection.
So finding the greater of two numbers. You've probably got that down. A simple if-else handles that perfectly. But what about our new challenge? Finding the greatest of 3 numbers. See, now things get a little tricky, right? The logic gets kind of tangled. You can't just tell Java, hey, check if x is bigger than y is bigger than z. It doesn't work like that. Java needs a really clear step-by-step set of instructions, and that is exactly what our next tool is for.
And that perfect tool is the if-else-if ladder. This thing is specifically designed for those situations where you've got a bunch of different options, but you know only one of them can be the right answer. So what exactly is it? Honestly, the name is perfect. Just picture an actual ladder. Your code starts at the very top and checks the first rung, which is our first if condition. And here's the most important rule. Your program can only stand on one rung of the ladder. The second it finds a rung, a condition that's true, it does the work that's there, and then it jumps right off the ladder, completely ignoring all the other rungs below it. Let's walk through that flow step by step. The program hits the top, that first if. Is the condition true? Great. It runs that code, and boom, it's done with the ladder. But what if it's false? Well, no problem. It just steps down to the next rung, the first else if, and asks the question again. It keeps doing this, going down the ladder, rung by rung, until it finds a condition that's true. And if it gets all the way to the bottom and nothing was true, that's where the final else comes in. It's like a safety net, a default case. The bottom line is, only one block of code ever gets executed.
Okay, theory is one thing, but let's get our hands dirty and see this thing in action. It's time to actually build the code to solve our problem, finding the biggest of those 3 numbers. So first things first, let's check if x is our winner. To be the champion, what has to be true? Well, x has to be bigger than y, and it also has to be bigger than z. Both have to be true. That's why we use the double ampersand, the AND operator, to connect these 2 checks into one big question. If the answer to that whole question is yes, we print x, and we're done. Easy.
Okay, but what if x wasn't the big winner? The program just moves on down to the next rung on our ladder, the else if. Now, remember, at this point, we already know x is out of the running. So we ask the same kind of question, but this time about y. Is y bigger than x and also bigger than z? If that's a yes, then we print y and our job is finished.
And now for the final piece. What happens if that first if was false and the next else if was also false? Well, think about it. We've ruled out x, we've ruled out y. Through the simple process of elimination, who's left? It has to be z, right? It must be the greatest. And that's why our final else block is so cool. It doesn't even need a condition. It's our catch-all, our default answer for when every other check has failed.
Now let's trace this with our actual numbers. This is where it all clicks. We have x is 8, y is 17, and z is 9. Okay, first check. Is 8 greater than 17 and 8 greater than 9? Nope, that's false right away. So the program just moves on. It goes to the next check. Is 17 greater than 8 and 17 greater than 9? Yes, that's true on both counts. So what happens? It prints y, which is 17, and then it just exits the ladder completely. It never even looks at that final else block.
Okay, so our code works. It gets the right answer. That's great. But getting the right answer efficiently, that's even better. So let's move on and see how we can make our code a little bit smarter and really start thinking like a pro.
And this quote here really says it all. The goal is not just working code, but smart code. It's not just about getting it to run. It's about making it elegant and efficient. Every little operation you can save, it all adds up. Efficiency really is key.
So have a look at our second condition again. On the left, you see the code we just wrote. But on the right, that's a more optimized version. You see what's different? We totally got rid of the y greater than x check. The big question is, why on earth are we allowed to do that?
Here's the secret.
It's all about the journey the code takes to get here. For our program to even be at this else if block, what do we know for sure? We know that the first if condition must have been false, and that failure gives us a huge clue. It tells us that x is not the greatest number. We've already eliminated it. So, asking again if y is greater than x is totally redundant. We don't need to. All we really need to check at this point is if y is greater than z. That's it. See? By understanding the flow of the ladder, we just made our code a little bit smarter and a little bit faster.
All right, we've covered a lot of ground, but you're doing great. We've built a really solid understanding of this. Now let's just lock it all in with a quick recap of the most important rules to remember.
Okay, let's nail down the 4 golden rules for the if-else-if ladder. Rule number 1, order matters. A lot. The checks always happen from top to bottom. Rule number 2, there can be only one. Just one block of code is ever going to run. That's it. Rule number 3, the first true takes it all. The second the program finds a condition that's true, it runs that code and gets out of there. And finally, rule number 4, the else is your safety net. You don't have to have one, but it's super useful as a default case for when none of the other conditions are met.
So now you've seen how the if-else-if ladder gives us this clean, really efficient way to handle multiple choices. So I'll leave you with a little challenge. How would you use this exact same structure to solve a classic programming problem? Assigning a letter grade, an A, B, C, D, or F, based on a student's test score. Think about how you'd order your checks, and how this ladder structure makes a problem like that surprisingly simple to solve.